Hello and welcome to this video on what are hydrographs and what can they tell us about flooding. Before we begin, I would advise that you make sure you know the human and physical causes of flooding. So if you want to go over and recap those before we begin, then please do and return to the video. A hydrograph is used to show how long it takes for rainfall to reach the river channel. They are drawn after a flood event. And these are really useful tools because they can help us with flood management. So scientists and geographers, they can draw a hydrograph after there's been a storm, and they can plot the amount of water that entered the river during a certain time period and how quickly it entered the river channel. And that way they know if they need flood defences, where to put flood defences, and just generally how to, it just generally helps them with their flood management. They might also be called a storm hydrograph or a flood hydrograph, but they mean the same thing in this instance. So we're talking about hydrographs, but you might read it as a storm or flood hydrograph. A key word for this video is the discharge of the river. I'm going to be talking about this a lot, so I just want to make sure that we understand what it means. And it's the amount of water passing through a river in a particular time. So bear that in mind, write it down if you need to, and that key word is going to appear a lot. So this is a hydrograph or a storm hydrograph. We have got 3 axes, which makes it sometimes a little bit more confusing for people. Along the x-axis, we always have time. So when the flood event started, or when the rainfall started, and when the flood event finished. Then at this axis, we have precipitation or rainfall, and that's shown in millimeters. And in this axis, we have the runoff or the amount of discharge, and that's measured in cumecs. Secondly, I want to point out that the normal base flow is this area here. So this is the amount of water that's normally in a river. Whereas the storm runoff, this area, is the water that entered the river channel during this storm or flood event. So normal base flow, how much water is normally in the river, and how much water entered the river during a storm event. The bar chart is our rainfall. So when we are reading the bar chart, we need to go across to the precipitation axes. And remember that that's recorded in millimeters. The line graph is our discharge. If you remember, the discharge is the amount of water flowing through a river at a particular time. So as you can see here, after we had quite a lot of rainfall, the discharge of the river increased. So the amount of water in the river increased. This is really important up here, the peak discharge. Peak discharge is the highest amount of water that entered the river at a point. And if you think about this being a mountain, and the peak of a mountain is the top of the mountain, therefore the top of the discharge, or the peak discharge, is the most amount of water that was flowing through the river at a particular time. Peak rainfall is same again, but this time it's the highest amount of rainfall that occurred, or precipitation. Now we've got some other keywords here, and I'm going to go into this one in a bit more detail later on in the video. But the lag time is the difference between the peak rainfall and the peak discharge. So the difference between the peak rainfall and the peak discharge. And lag means something that happens after. So if you lag behind someone, that means you're struggling to keep up with them. You are behind them. So a short lag time would suggest that the water entered the river and the river reached its peak discharge really quickly. A long lag time suggests that the discharge was much further behind the rainfall and it took the rain a lot longer to enter the river channel. We also have the rising limb, which is just the name given to when the discharge is increasing, and the falling limb, which is the name given to when the discharge is decreasing. Right, I'd now like you to pause the video and point to the definition of discharge. It's B, the amount of water passing through a river in a particular time. If you just write this in an exam, then you won't get the full mark. You must mention the link to time with discharge. Okay, there are 4 factors that affect the discharge during or after a flooding event. And we're going to go through each of them. So our first one is the size of the drainage basin. And we're just going to look at this one quite quickly. So the drainage basin, remember, is the total area drained by a river. So if it's a small drainage basin, there's not going to be very many tributaries joining the main river channel. And so we're probably going to have a small amount of discharge. There's not going to be much places for the water to go, but the water is reaching the river quicker than in a large drainage basin. So if you think about this potentially being where the rainfall happens, the water has reached the river channel much quicker in a smaller drainage basin than a larger drainage basin, but the total discharge is much smaller. Next is vegetation. And this one's a really important one and is likely to crop up in your exam. So we've got bare vegetation, or where there is no vegetation, and in this line it's where there is a forest. Now a forest has got a much lower discharge and a longer lag time. If you think about this being the peak discharge, it's happened after the peak discharge for the bare vegetation area. And the reason being is that the leaves on trees or plants can intercept the rainfall. So they stop the rainfall from reaching the river channel. So if there are trees or a forest in the way, then some of that rainfall will not enter the river channel and will instead stay on the leaves and be intercepted by the trees. So having a forest is actually a really good way of trying to stop flooding from happening, because the water will be intercepted. In an area with very little vegetation, all of that rainfall has got to go somewhere, and so it's probably going to end up in the river channel. It will join the tributaries and it will join the main channel. And this will mean that the water entering the river will get there much, much quicker and is likely to lead to more water in the river. So we have a higher peak discharge and a shorter lag time. Next is the valley side steepness. So if you think about a valley having really steep sides, the water is probably going to rush really, really quickly down the sides of those valley. Whereas really gentle sloping valley sides, it's going to take much longer for the rainfall to enter the river channel. So here I put that there's a faster surface runoff into the river in a steep valley. Remember that if the rain is falling, gravity will mean that the water will rush into the river channel really quickly in a steep valley than it will a gentle valley. So therefore, the peak discharge will be reached much quicker in a steep valley than in a gentle valley. Lastly is the soil or surface type. Now we've got 2 key words here which you should be familiar with by now: impermeable and permeable. So impermeable surfaces means the water cannot infiltrate the surface, so there is more surface runoff. So this is really common in urban areas. In urban areas, you might see a hydrograph this shape, because the soil, which allows water to infiltrate through it, has been replaced with impermeable surfaces like concrete. And this will not allow the water to go through it. It cannot infiltrate it. So instead, it remains a surface runoff and flows along the surface of the concrete or the road into the river. Permeable surfaces do allow the water to infiltrate. So rather than it all rushing into the river channel, some of it will seep into the soil beneath it and hit the groundwater flow. This will mean that the water will take much longer to reach the river channel, so the lag time is much longer and the peak discharge is much lower. Okay. I would like you to point to where it will flood the quickest, either this image or this image. It's the top one. The reason being for this, we can see there are lots of impermeable surfaces. So the water's not going to be able to infiltrate these areas of land around the river. They're going to stay along the top of the river and probably rush into the river. So this city here is actually Tokyo, and the urban planners of Tokyo are going to have to think very carefully about the flood management that they use and include, because it's going to be very necessary along this river. This picture here is likely to have a very, very small flood event if they have a flood event at all. And the reason for this is we can see that there are lots of forested areas. There's lots of vegetation which is able to intercept the rainfall and stop it going in the river channel. And there's lots of permeable surfaces, so the water will be able to infiltrate through the soil and not end up in the river channel. Okay, so this is a hydrograph that you might see for these 4 reasons. If it's in an urban area with lots of impermeable surfaces, or if there are steep valley sides or very little vegetation. So as we can see, impermeable surfaces means that the water will not infiltrate, so it will rush straight into the river. This means that after the rainfall event, remember the bars represent rainfall, the water will enter the river channel much, much quicker. So we have a very steep rising limb. This is showing the water entering the river channel really quickly, and a high peak discharge. And remember, the difference between the peak discharge and the peak rainfall is the lag time. So the lag time here is actually very short. It's only about 24 hours, if that. We've got half a day, 1, next to half a day, 2. So it enters the water really quickly and it leaves the river really quickly. But for this kind of hydrograph, you will see for urban areas with impermeable surfaces, or if there are really steep valley sides, or if there is no vegetation. Okay, so no vegetation means that the water is not going to be intercepted by the leaves, so it will enter straight away into the river channel. Steep valley sides means that the water will rush down the valley sides much, much quicker to enter the river. And impermeable surfaces in an urban area means that the water cannot infiltrate, so will remain as surface runoff flowing into the river channel. This hydrograph you can see is quite different to the previous one. We have a much, much lower peak discharge, a much, much gentler rising limb, so the water is entering the river much slower, and therefore we have a much longer lag time. This time it's almost 2 days, so almost 48 hours. And you might see a hydrograph like this if there is a rural area with permeable surfaces. So remember, permeable means the water can infiltrate the soil, so it won't necessarily end up into the river channel. If there are gentle valley sides, so therefore the water will take longer to flow into the river channel, or if the area is forested or if there's lots of vegetation. So remember, the leaves then will be able to intercept the rainfall and it will stop it entering the river channel, meaning that the discharge is much lower. I would now like you to point to the definition for lag time. It's A, the delay between the maximum amount of rainfall and the peak discharge. And it's not B, because this one just says that it's the difference between the rainfall and discharge. It hasn't specified that it must be the peak rainfall and the peak discharge. I'd now like you to point to which locations would have a short lag time. So you can pause the video and then point to the 2 locations with a short lag time. This is definitely one of them. So this here we can see is in a maybe an arid area. It's got really hard ground. It might have suffered from drought. If there was to be a rainfall event, then the ground is so hard that it's unlikely that the water would be able to infiltrate through that soil. So instead, it would remain on the surface and flood really quickly. And that's why in deserts and arid areas, we get lots of flash flooding. And flash flooding means flooding that happens really, really quickly because the ground is so hard, the water cannot go through the soil. This location would also probably flood the most. And again, we can see that it's an urban area with lots of impermeable surfaces. And so the water will not be able to infiltrate through the ground. It will stay as surface runoff and enter the river channel. This location is unlikely to flood because we've got lots of vegetation. So you can see all of these really tall trees along the riverbanks that will intercept the rainfall and stop lots of it entering the river channel. This location also unlikely to flood. Here we can see that there is the river, and again around the river we have lots of vegetation, and we're also surrounded by lots of permeable surfaces. So farmland has got lots of good soil, so the water can infiltrate through the soil. Now, we also need to know how to calculate the lag time. Remember, the lag time is the difference between the peak discharge and the peak rainfall. So the highest amount of rainfall is this bar, and the peak discharge is over here. On this graph, however, the axes have changed. We now need to read rainfall over this side and discharge over this side. They can swap which axis shows which variable. So it's really, really important in an exam that you read the graph really carefully to make sure that you're reading the correct axes for each variable. So therefore, to calculate the lag time, we get the peak discharge and we take away the peak rainfall. So in this case, we've got about 11 hours to get the peak discharge, and the peak rainfall happened at about 7 hours. So 11 minus 7 is 4. So now I'd like you to pause this video and have a go at calculating the lag time yourself for this question here. So pause the video, have a go at calculating the lag time in 3, 2, and 1. Okay, welcome back. Hopefully you managed to get a lag time of 5 hours. So we can see the peak discharge is about 8 hours. Maybe a tiny bit more. So if you said maybe 8.5, then I'll allow that. And the peak rainfall, this bar here, which was at 3 hours. So 8 minus 3 is 5. So if you said it was 8.5 minus 3 and you put 5.5 hours, that would also be allowed. I now would like you to pause the video and point to the answer that shows the lag time for this hydrograph. So pause it in 3, 2, and 1. Okay, you should have got 42 hours. So here our peak discharge is at about 60 and our peak rainfall is at 18. So 60 minus 18 is 42 hours. It's not 30 hours because 30 would have been 60 minus 30. And remember, it's not the end of the rainfall event, it's the peak rainfall for the lag time. So peak discharge minus peak rainfall. Okay, I'd now like you to point to which hydrograph is most likely to be for a forested area with permeable surfaces. It's the bottom one. So a forested area with permeable surfaces. Remember, forests will have lots of leaves that can infiltrate the rain. So therefore, not all the rainfall will enter the river, leading to a lower peak discharge. And permeable surfaces means that the rain can be infiltrated into the soil and therefore not necessarily enter the river channel. So we've got forest leaves intercepting the rainfall so it doesn't enter the river, and permeable surfaces meaning that the water will infiltrate the soil and not necessarily end in the river. Okay, I would now like you to pause the video and have a go at this gap fill exercise. If you want to make it a bit harder for yourself, try covering up the bottom of the screen which has the key words and have a go at filling in the gap fill by yourself. So pause the video for about 4 to 5 minutes in 3, 2, and 1. Okay, welcome back. We will now go through the answers together. So a hydrograph is used to show how long it takes for rainfall to reach the river channel. They are drawn after a flood event and can be used to help with flood management. The difference between the peak rainfall and peak discharge is called the lag time. Areas with impermeable surfaces will have a shorter lag time than areas with permeable surfaces because the water cannot infiltrate. Forested areas have a long lag time and a low peak discharge because the water can be intercepted by the leaves and then infiltrate into the soil. So remember, hydrographs might also be called storm or flood hydrographs. They are drawn after a flooding event to help planners with flood management, and they can be drawn differently, and the way that they are drawn gives you an idea about what the area might have been like. So a short lag time and a high peak discharge is likely to have been maybe in an urban area with impermeable surfaces, or an area with low vegetation, or have a steep valley sides, or be a smaller drainage basin, would have a shorter lag time. Okay, thank you very much for watching. Goodbye.